Welcome back to our channel, viewers. Now today we want to deal with this radical geometry problem. How do you find the length OC? Now to get the length OC, we shall connect the center of the inscribed circle with the tangent points. So we can let this point to be x, that tangent point to be x, and this tangent point here to be y. Now, for any two intersecting tangent lines, they are always of equal length. So you can see from x to b, the tangent x to b and the tangent y to b are intersecting at point B. So if the length xb you let to be a, then the length by will as well be a. So if from a to b was 12, then from a to x will be 12 minus small a. And you can see the tangent, if you let this point here, maybe to be the point Z. So you see the tangent XA is intersecting with the tangent ZA. So it means the length x to a, which is 12 minus a, will be the same as the length z to a will also be 12 minus a. Intersecting tangents are always of equal length. So if the length from A to C is 13, then it means the length from Z to C will be 13 minus 12 minus A. Because from A to Z is 12 minus A, and from A to C is 13. So it means from Z to C is 13 minus 12 minus A. If you open that bracket, you will get that length. 13 minus 12 is 1, negative into negative, plus A. So you can see the length from Z to C, the tangent from Z to C intersecting with the tangent from this point Y to C. So if from Z to C is 1 plus A, then from C to Y will also be 1 plus A. Now what do we have here? We now have the length from B to C is A plus 1 plus A. So A plus 1 plus A will be 1 plus 2A. Then the length from A to C is just 13. And again, the length from A to B is just 12. So if you use Pythagoras theorem, the hypotenuse squared, the Pythagoras theorem, AC squared will be AB squared plus BC squared. Pythagoras theorem. So if you substitute the value of AC from A to C, we have is 13. So that is going to be 13 squared to be equals to AB squared. From A to B, we were given to be 12. So that is going to be 12 squared plus BC squared. From B to C is A plus 1 plus A, which is 1 plus 2, 1 plus 2A. So it is going to be 1 plus 2A squared. So if you work out this, 13 squared is 169 to be equals to 12 squared is 144. Then plus, if you open this bracket, 1 plus 2A squared will be 1 plus 4A plus 4A squared. So here we'll have 169 to be equals to 144 plus 1 is 145 plus 4A plus 4A squared. Now for you to remain with 0 this side, we will subtract 169 on either side of the equation. If you subtract 169 on the other side, 169 minus 169 is 0. 145 minus 169 is negative 24. Then it is plus 4A plus 4A squared. Now we can simplify this equation by dividing all through with a common factor. You divide all through by 4, which is a common factor. So what will we have? 0 is equals to 24 divided by 4, that is negative 6. 4 goes with 4 plus A, 4 goes with 4 plus A squared. So if you rearrange that, you start with A squared plus A minus 6. So we have A squared plus A minus 6 is equals to 0. So if you solve this equation, what is the value of a? You see the coefficient of a here is 1. The coefficient of a squared here is 1. This coefficient is also 1. So if you solve that, what is the value of a? I will go to mode, then equations number 5, then quadratic equation is number 3. Then the coefficient of a squared is 1. I key in that to be equals to coefficient of a is also positive 1. Key that, then coefficient of c is negative 6, the constant term is negative 6. So after that, what is the solution? The first solution of a, which is given in terms of x, is 2. So it means a is 2, and the second solution of a is negative 3. So we have a is equals to 2, or a is equals to negative 3. So because a is a length, then the positive value is what we represent a length. So we found the value of a is 2. So a is 2, meaning from x to b was 2. Then here is 12 minus 2, which is going to be 10. Then here was 12 minus 2 was as well going to be 10. Then here was that 1 plus 2 was going to be 3. Then here we have a was 2. Then here you have 1 plus a. 1 plus 2 is 3. Then it means if from x to b is 2, then from o to y is also 2. Now, if you look at this, for you now to get OC, that is just Pythagoras theorem. Use triangle OYC. So if you take triangle OYC, now if you take triangle OYC, so triangle OYC, you use Pythagoras theorem, you can see OC squared is the hypotenuse is OY is equals to OY squared plus YC plus YC squared. So if you substitute, you get OC squared is equals to OY. From O to Y we found is 2. That is going to be 2 squared plus YC. From Y to C we found is 3. That is going to be plus 3 squared. So we get OC squared is 2 squared plus 3 squared is 4 plus 9. So you will have OC squared is 13. So for you to get OC, you look for the square root on both sides of the equation. So the length OC is root 13. Ladies and gentlemen, that is the simplest means to solve that radical geometry problem. Thank you for watching and see you again in our next presentation.